everyone. In this video, we're going to go over how to name molecules that have rings in them. So last time we saw that if we have a chain of carbons, we want to find the longest chain, and then we use a prefix to indicate how many carbons we have, followed by ANE. So this will be pretty similar, except the carbons are in a ring or in multiple rings. So let's say, for instance, that we have a molecule with a ring here. And let's say there are some substituents on the ring. In this scenario, the ring is the parent. So instead of counting the longest chain, here we're just considering that the ring is the parent. Now there are exceptions to this. For instance, if you have a really small ring with a long chain of carbons on it, that would be different. But for the most part, the ring will be the parent. All right, so now we need to learn how to number the ring and also name it. So let's go to rule number 2. The substituent with the lowest priority should be at carbon number 1. So what do we mean by lowest priority? So all this means is we're going to alphabetize the substituents. And whichever substituent comes first has lowest priority, so that will be at carbon number 1. So for instance, in the molecule down below, we have a methyl substituent and an ethyl substituent. So ethyl starts with E, methyl starts with M, so we would number the ring starting at ethyl because it comes first in the alphabet. All right, so we'll put that at carbon 1, and I'll just go clockwise around the ring. Okay, now normally we want to minimize the numbering of the substituents, but in this case, methyl and ethyl are directly across from each other. So whichever way we number it, whether we number it clockwise or counterclockwise, methyl will always be at position 4, so that works out. Okay, so we have 6 carbons in the ring, so that means we want the name of this molecule to end in cyclohexane. Oops, that looks like hex ants. Hexane. Okay, so you'll notice we added the word cyclo in front of hexane. And the cyclo tells us that we have a ring system. Hexane tells us we have 6 carbons in the ring. Okay, so next we have to list the substituents. So again, ethyl goes first, and it's at position 1. So we'll write 1-ethyl dash, and then methyl's at the 4th carbon, so we'll write 4-methyl. So the full name for this molecule is 1-ethyl 4-methyl cyclohexane. So not too bad. It's pretty similar to how we were naming alkanes in the previous video, except we added the word cyclo in front of hexane. Now let's look at some more complex ring systems. So what if we have 2 rings? All right, so let's say we have bicyclic rings. So let's look at an example. So I'm going to draw a molecule down below that has 2 ring systems. Okay, so this might be kind of hard to visualize, but there are 2 rings in this molecule. So let me actually highlight the rings so you can see them. So there's a ring over here, and then there's also a ring over here. So they're attached through that middle portion. I just noticed I used duck's colors. Must have been subconscious. So anyway, let's redraw this ring because I want to show you how to name the ring. Okay. So first of all, we're going to count all of the carbons that are in the ring systems. So remember, every vertice is a carbon. So we're going to start at the top. 1, 2, 3, 4, 5, 6, and then there's 7 right in the middle. Okay, so this would be, let's see, which prefix do we use for 7? Hept, so H-E-P-T. Heptane. Now, I'm not going to put cyclo in front of heptane directly because cycloheptane would tell me that I have a 7-carbon ring. But here we have 2 rings, so we have to name this slightly differently. Now, in the next step, we're going to determine what are called bridge lengths. So on the left-hand side, we have 1 bridge. On the right-hand side, we have another bridge. And in the middle, we have a 3rd bridge. So these are all referred to as bridge, bridge heads. Okay. Now what we're going to do is count the number of carbons in the middle of each bridge. So on the left-hand side, highlighted in yellow, there are 2 carbons in the middle of that bridge. So we call this a 2-carbon bridge. So we're not counting the carbons at the ends. Then on the right-hand side, we'll do the same thing. So that is also a 2-carbon bridge. And in the middle, our purple bridge, we have 1 carbon. Okay, so now in brackets in our name, we're going to list the bridge lengths from largest to smallest, and we'll separate them with periods. So this will be 2, period 2, period 1. Okay, so now the last thing we have to do is put cyclo in here to indicate that we have a ring system. So we're actually going to put BiCyclo in front of the brackets. So bi means 2, and then in the middle we have our bridge lengths. And at the end, we indicate how many total carbons we have. All right. Now, let's say we had a substituent on one of these carbons, like a bromine or a chlorine or something. We would number the circles starting with the largest ring, and then we would move to smaller rings after that. And we would start at a bridge head. So for instance, where the purple meets the yellow meets the green. Now on this one, the rings are the same size, so it doesn't really matter where we start or how we number it. But we'll see some examples later on of how to do that. Speaking of which, let's go over some more examples. Okay. So let's start with one that's a little easier to visualize. Okay, so here we have two very easy rings to see, and they're connected by a bond in the middle. All right, so again, the first thing we want to do is count the total number of carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 total carbons, so which prefix should we use? Non, N-O-N. So this would be non-ane. All right, and then the next step, we have to figure out how long each of the bridges are. So let's highlight our bridges. One bridge is on the left. One is on the right. And there's actually one in the middle. Okay, so let's count the carbons that are in the middle of each bridge. So if we start with the yellow bridge, we have 1, 2, 3, 4 carbons. All right. And then let's look at the blue bridge. We have 3 carbons. And now in the middle, the purple bridge. This one's a little tricky. How many carbons are in the middle? 0. So remember, we don't count the carbons that are at the ends of the bridge. We count how many carbons are in the middle. So this would be a 0 carbon bridge, which is a little strange. All right, so in brackets, we're going to write from largest to smallest, 4, period 3, period 0. And then in the front, because we have 2 rings, we'll write bicyclo. Okay, so let's try another one. And this one will look really similar to what you've seen already on your pods from last, or a couple weeks ago, I guess now. So we have this structure here, and then there's actually a bridge going up and over. So let's start by counting the total number of carbons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and just a quick note, remember that this point where the bonds cross each other, that's not a carbon. And I'll try to make that clear on exams, so I'll try to show that one bond is crossing another bond. But just something to keep in mind here. Okay, so I'll just erase that arrow there. So if we have 8 carbons, which prefix should we use? Oct. So we would end this name with octane. All right. So now we have to count our bridges and how many carbons are in each. So on the left-hand side, we have this bridge. On the right-hand side, we have that bridge. And in the middle, we have our purple bridge. And that might actually be easier to visualize what's going on there with the purple bridge. It's kind of coming up and over. All right, so let's count how many carbons are in the middle of each bridge. So on the left-hand side, our yellow bridge, there's 2 carbons in the middle. On the right-hand side in blue, we have 2 again. And what about the purple bridge? How many carbons are there? 2. All right. So that means in brackets, we're just going to write 2, period 2, period 2. And of course, in front, we're going to write BiCyclo. Okay, let's do one more example, and this time we'll add a substituent. So we can see how to name a bicyclic ring system that has a substituent attached. Okay, so this time we have a bromine attached to our ring system. Okay, so let's start how we normally would. Let's count how many carbons we have. So we have 1, 2, 3, 4, 5, 6. So which prefix would we use? Hex. So this would be hexane. All right, and now we have to count our bridge lengths. So let's highlight our bridges. We have one on the left. We have one on the right. And we have a bridge in the middle. So how many carbons are in the bridge on the left, the yellow bridge? 2. How many are on the right in our blue bridge? 2. And how many are in the middle? 0. Okay, so that's very similar to our first example. So in brackets, we're going to write 2, period 2, period 0. So remember to list them from largest to smallest. Now, in front of that, we are going to write bicyclo, but in front of that, we're going to write our substituent, which is bromine. Now, if bromine is a substituent, we actually call it bromo, and we would do the same thing with chlorine or fluorine. It would become chloro, fluoro, etc. So actually in our essential oils lab, we use dichloromethane. So again, chlorine was listed as chloro because it's a substituent. All right, so we have to figure out though where bromine is on this ring. We have to give it a number. So remember on a couple slides ago, or the last slide, number 3 said number the rings starting at a bridgehead around the largest ring, then progressively move to smaller rings. Now, in this situation, the largest ring is just the outside of this. So I'll just number it for you so you can kind of see what that looks like. So we're going to start at the bridgehead. So we'll start up here. That would be carbon 1. And we want to minimize the number for the substituents. So I'm going to make bromine number 2 here, or it's on the number 2 carbon. And then we'll just keep going around this largest ring. All right. So we've given bromine the smallest number possible. If we had numbered it the other way, bromine would be at position 6, which we don't want. We want it to be at position 2 because it's smaller. All right, so then we write 2 bromo at the very front of this molecule. So this is a bit of a longer name. It's 2 bromo bicyclo 2,2,0 hexane. All right. Now, these ring systems don't come up that often, but they will come up in this class, so you should know how to name these ring systems. And if you want more practice naming ring systems, I recommend the Skill Builder 4.5 exercise on page 144. And that will walk you through some more examples. All right, so I think I'm going to end the video there because our next topic is something called conformational analysis. So we're going to start looking at Newman projections, which I had shown you on the very first slide for chapter 4. So I will see you then.